Hey everybody, my name is Scott, and today we're going to solve the bulb switcher problem on LeetCode. This problem is kind of interesting. It has a constant time solution, which is unlike any problem I've done, or we've done in any of these videos so far. Let's run through the definition of the problem. We have n bulbs that are initially off. You first turn them all on, then you turn off every second bulb. On the third round, you toggle every third bulb, toggling being turning it off if it's on it if it's off. And then in the ith round, you toggle every ith bulb, nth round, you toggle the last bulb. How many bulbs are on after n rounds? So they give us an example. For n equals to 3, first, they're all off, right? That's the initial state. After the first round, we turn them all on. In the second round, we toggle the second one to being off. The third round, we toggle the last one to being off. So we end up with one bulb being on. So let's implement this problem. And it's going to be pretty simple. We're going to do floor on the square root of n. That's going to return a double. I'm going to cast it to an int. Floor has two O's in it. Let's see how that works. Alright, so it compiles. Let's see if it will actually be an accepted solution. And it is. So that is a one-line solution to this problem. Now, there is all kinds of clever math going on behind the scenes here, and I'm not going to lie to you, it's clever math that I don't entirely understand actually. The way I was able to solve this problem was exemplifying the problem. And if you're trying to figure out a way to solve problems in general, especially things that are really tricky like this problem is, you know, returning the floor of the square root function it doesn't really make any sense at first. Like if you were to walk in and somebody asked you to solve this problem in an interview, you know, you'd probably be a little terrified at first, right? So I solved this problem in about 10 minutes or so. And like I said, the way I did it was using something called just exemplification. They talk about it in some of the other books here when you're trying to come up with algorithms. I literally just kept writing down numbers and seeing how they came out, seeing what the result was. What I ended up noticing was that it goes in odd numbers. So we start with 0, and then there's 3 ones, there's 1 0, 3 ones, 5 2s, 7 3s, and so on. Couldn't really figure out what to do with that. And then when I started looking at the numbers, I noticed that the numbers jumped at square roots. So 0 goes to 0, and then 1 goes to 1. But then we go to 2 at 4, and then we go to 3 at 9, and so on. So it just becomes a square root function. So, like I said, I was able to solve this problem in about 10 minutes, and I don't understand the math that's going on behind it. Some really, really smart people do. The way I was able to get to the solution was literally just exemplifying it. So if you're ever faced with a problem that you don't really know where to start exemplifying it, which is to say, start writing down inputs and mapping them to outputs, and then start looking for a pattern in those that you can use to solve the problem. So that's it for this one. Probably the easiest, or the simplest, easiest and simplest probably isn't right, shortest solution we'll ever have on here. And like I said, I'm no math genius or anything to be able to figure this out. I solved it in about 10 minutes just by exemplifying it. And again, exemplifying it was just writing down inputs. I did 0 through 25 before it hit me what was going on, right? I did 25 of them, and then I just looked for a pattern in how the outputs were coming out. And that's how I got to an answer. So you don't have to be a mathematician to figure this stuff out. You just got to be able to map inputs to outputs and look for a pattern in it. So that's it for this one. We'll see you next time.